Hello, everyone, and welcome to another in the TerraSource Global series of webinars. Today's topic is Coal 101, a relatively brief and general overview of TerraSource Global's involvement with coal. My name is Jack Logue, and it's my pleasure to be your presenter today. I've been with TerraSource Companies for almost 37 years now, and I'm currently Director of NAFTA Sales. Today's agenda will cover the following topics. What is coal? Where is it found? Some general coal facts, a summary of where coal is used, and then specifically we'll talk about coal mining, coal preparation, coal in power generation, and coal in steel production. What is coal? Coal is basically made up of four elements. It's formed from organic material from prehistoric times that's been subjected to millions of years of pressure. Coal is a combination of fixed carbon, volatiles, water, and ash. And its quality varies with the type of vegetation from which it was formed, the depth of the burial, how deeply it's buried in the earth, and the temperature and pressures at those depths, and how long it's been buried. Coal is ranked or categorized by the degree of time that it has been in place and what transformation has taken place during that time. Generally, coal is ranked by caloric value. As the rank increases, the fixed carbon and volatiles, the fixed carbon increases while the volatiles and the water content decrease. Therefore, its heating value increases as its carbon content increases. There are four major ranks for coal. Anthracite is the oldest, and it has the highest caloric value, 13,000 to 15,000 BTU per pound. Anthracite coal is found in eastern Pennsylvania and in China primarily. Bituminous coal is probably the most common type of coal and is found throughout the world. It is a mid-range coal with caloric values 10,000 to 14,000 BTU per pound. It's abundantly found throughout the world, especially in the United States, Russia, India, Colombia, China, Australia, for example. The next lower ranked coal is subbituminous coal. Subbituminous coal is primarily found in the western United States in the Powder River Basin of Wyoming and Colorado. Subbituminous coal has a BTU content of 8,000 to 10,000 BTU per pound. And it's popular because subbituminous coal generally has lower sulfur levels than other types of coal. We'll talk more about that when we talk about power generation a little bit later. The lowest ranked coal is the lignite coal or lignitic coals, which are the lowest caloric value and are the youngest, if you will, of the coal ranks. It's generally found in Germany, in the CIS, in Australia, and in a few areas of the United States, North Dakota, Texas, and Mississippi. Generally, coal like lignite, lower ranked coals, if they are used close to the mine site because their caloric value does not justify shipping them over long distances. Where is coal found? Generally, it's found throughout the world, with the largest deposits being in China, Russia, and the United States. These three areas account for about 60% of the coal in the world. The next areas would be Australia, Indonesia, and India. There are deposits in Canada, South America, Europe, and South Africa. This chart depicts where the world's coal resources are located. Again, as you can see, the United States has the majority or a large percentage of the coal found in the world, with second, Russia and China. This chart is a chart of global coal production rather than where the resources are located. This chart shows where coal is taken out of the ground and mining and used. As you can see, by far, China right now is using the most, mining and using the most coal in the world. The United States only using about 13% compared to China, which accounts for about half the world's global coal production. This chart provides an idea of where coal is being consumed. Again, we can see as the standard of living improves in Asia, there's a huge and growing demand for coal, both for power generation and steel production. To fuel the technology advancement taking place, China is relying on coal, much like the Western economies did in the early 20th century. Interestingly, you can see that the United States consumption slowly increased from 65 to 2010, but beginning with the recession in 2008 and continuing with the current environmental restrictions and regulatory climate, coal usage has been relatively flat. Here's some interesting coal facts, general coal facts. The world has about 700 billion tons of proven thermal coal reserves. As I mentioned earlier, the majority of that's in the United States, Russia, China, and India. At the current rate of removal or usage, the world has about 140 years of supply at the current demand levels. Currently, we're using about 5 billion tons a year of coal worldwide. Let's talk generally about how coal is mined. Coal is mined both on the surface and in underground mines. Surface mining involves removing the overburden, which is the soil and rock above the coal, and then removing the coal with shovels, bucket wheel excavators, loaders, etc. Here's a typical surface mine. You can see in the background, there's a large drag line. Back here, that's stripping away the overburden and can dig into the coal. The overburden's up here. All this is removed to get to the coal seams, which are below. Then you have loaders, which load trucks, and then they take the coal to a processing plant, which is where the TerraSource equipment would be located. About 40% of the world's coal is surface mined. And surface mining is used throughout the subbituminous coal fields in the western United States, where seams of coal can be as thick as 50 to 100 feet thick. Underground coal mining accounts for the other 60% of coal mining. Basically, coal is mined in one of three ways underground: either continuously mined, longwall mined, or conventionally mined. We'll discuss each of these just real briefly. This chart breaks down the percentage of coal by how it is mined underground. About 50%, it's almost an even 50% split between longwall and continuously mined coal, with conventional mining only accounting for about 2% of the coal that's mined today. Continuous mining uses a network of rooms cut into the coal seam. A large rotating drum head, as you see here, scrapes coal from the seam and loads it continuously onto a shuttle car. Continuous mining uses what we call room and pillar method. Here's a schematic which shows what we're describing. You see the large shearer, which is cutting the coal away from the face, and then it loads onto a shuttle car, and the shuttle car takes the coal to the belt that takes the coal to the surface. The pillars support the roof, and eventually they can be taken, but they're used as supports in a continuous mine application. Longwall mining, again, accounts for nearly the same percentage as continuous mining, but the recovery rate for longwall mining is higher than the recovery rate for the continuously mined coal. Actually, in a longwall mining situation, they can recover up to 75% of the coal that's available to be taken. It's more expensive than continuous mining coal, but the recovery rate is higher. In a longwall mining situation, multiple shearers mounted on a series of self-advancing hydraulic ceiling supports support the ceiling and at the same time take the coal away from the face. As the shearers cut coal from the face, the miners are backed out and the roof is allowed to collapse behind the miners. Here's a schematic which describes that. The coal is being mined, and as it's mined, the roof supports advance with the miner, and then the roof material collapses behind the miner as it advances. A couple of pictures of a longwall miner as it's working the face of the coal seam. Up above here you can see the roof supports here, and the cutting drum. Conventional mining is not a continuous process, but rather a situation where the coal is taken in a series of blasts. The coal is cut, holes are bored into the coal surface, explosive charges are put in, and then the coal is blasted, the broken coal is then loaded, and the process is repeated. It's what we call cyclic mining, and it's generally done in small mines because of the limited production. Still, only a very small part of the way coal is mined today. Once coal is extracted from the mine, it must be cleaned. That is, the ash, the rock, must be separated from the coal, and this is called coal preparation. Here we have a typical coal preparation plant where the cleaning equipment is located in these buildings and the coal is coming up from underground. Coal must be cleaned to remove the rock and other impurities, and generally only anthracite bituminous are worthwhile cleaning. Subbituminous coal can generally be used just as it comes from the mine, and lignitic coals are also used. Because of their low BTU value, it's definitely not worth cleaning them, and so that limits where they can be used compared to the anthracite and the bituminous coals. There are several methods used to clean the impurities from coal. These include heavy media separation, jig washing, and screens and picking tables. Bradford breakers, which we'll talk about a little bit later, are used to make a primary separation based on the difference between the coal hardness and the hardness of the rock. Generally, the coal is softer than the rock and can be separated by lifting and dropping. Heavy media separation and jigs use the difference in coal density compared to the rock to do the separation. Coal is generally lighter than the rock, and when both are put in a bath of liquid, can be separated where the coal will sink to the bottom, or the rock will sink to the bottom, and the coal will float on the media. Generally, coal needs to be sized to about -6 before it goes to the preparation plant. And then once it's cleaned and washed, it's generally shipped at about 2 to 3 inch in size. Preparation plants are tending towards trying to use larger and larger feeds because generally the coarser the size coming into the plant, the less costly the separation process. If a lot of fines are created, a lot of very fine material, it's generally harder to separate that material from the coal, and it's really considered a waste material, requires a lot of work to process it to make it usable. This is a list of the equipment, the TerraSource equipment that's used in coal mining and preparation. In the primary separation, we can use Bradford breakers, we can use sizers, we can use single roll crushers, we can use multiple roll crushers, our double and quad roll crushers, and we can use our Jeffrey Rader flex tooth crushers and feeders. Here's a Bradford breaker. What it is a big cylinder where the coal and rock come in one end. It tumbles the coal, it lifts the coal and the rock. The coal, being softer, will break down and be screened out and collected under the breaker. The harder material, the rock, the timbers, the uncrushable material, travels down the cylinder and is scooped out by this scoop and is collected in a separate pile. Here's our sizer and our roll crushers. The idea with the sizer and the roll crusher is to do the primary sizing of the coal without creating a lot of fine material before it goes to the preparation plant. And then, of course, we're able to use our vibrating feeders in a variety of applications at the preparation plant. The most common use of coal throughout the world is in the generation of electricity. This is a typical 2-unit coal-fired power plant, 2 boiler generating units, and the belt that comes from the coal yard. You see the coal yard in the foreground, and the belt that comes up to the plant. Between the two, coal can be crushed down in this building and sent to the plant, where further crushing is done inside the plant, and then the generating units. As mentioned earlier, coal is used to generate about 45% of the world's electricity. This pie chart shows the breakdown by fuel in the world's generation mix. There we see coal in this portion, natural gas, about 20%, but that's growing in areas as fracking and techniques to get more gas out of the ground have improved. Coal's proportion has been sinking, natural gases has been increasing. In the generation of electricity, coal is used as the energy source to heat water, in the boiler, create steam. The steam is then used to drive a turbine, which is connected to a generator, and this produces the electricity. The steam is condensed and reused in the process after it goes through the turbine. Here at TSG, our interest is in the use of coal in electric generation, centers around the coal sizing that is correct for the particular boiler type. There are several types of boilers used in electricity generation. The most common being the pulverized coal boiler, the second most popular, the fluidized bed boiler, and then there are cyclone boilers and stoker-fired boilers. Pulverized coal boilers are the traditional technology for large generating plants. Pulverized coal plants can use a variety of quality coal, and our crusher, the TerraSource crushers, are generally followed by a pulverizer, which does the final sizing before the coal is fed to the boiler. The exact product size required from our crushers is not critical because the material from our crushers is going to be fed to the pulverizer. Generally, our crushers can make anywhere between a 3/4 inch to 2 inch top size, depending on the type of pulverizer that follows it. The boiler manufacturers typically supply their own pulverizers. When coal is finally pulverized and fed to the boiler, it's generally the consistency of face powder when the pulverizer gets done with it. This is generally about 200 mesh in size. Fluid bed boilers is a more recent technology that's been used in the energy generation field for about the last 30 years. In a fluid bed boiler, the fuel and a sorbent are mixed in the bed of the boiler and burned at the same time. The crushers, our crushers in a fluid bed boiler application, produce the final size that's fed to the boiler. There is no pulverizer. Our crushers produce an output size, and that is used in the boiler as is. Because of this, the entire crusher output gradation is critical to the boiler performance. And a lot more work goes into the selection and setup of a crusher in this application than with a pulverized coal application. The advantage of a fluidized bed boiler is that it can burn a variety of fuels, not just coal. We're interested in coal. As I mentioned, generally, the fuel and the sorbent are mixed together in the bed of the boiler. The sorbent is usually a limestone or a lime, and the sulfur in the coal combines with the limestone to form calcium sulfate, which is like a gypsum material, and this removes the sulfur from the emissions of the boiler before it goes up the stack. So the boiler tends to be much cleaner than a pulverized coal boiler, where the scrubbing on the stack emissions from a pulverized coal boiler needs to take place on the back end as a separate process. In a fluid bed boiler, the removal of the sulfur is done in the bed of the boiler. Here's a typical power plant located on the river. See, barges bring the coal in. Coal is transported to the crusher house or out to the coal pile. And this is where the crushers would be located in this instance. Coal comes up the belt and into the power plant. Coal in this instance is coming in by river. Here is another typical plant. The interesting thing about this plant is the coal is delivered by train here. This is located on a lake. Crusher house and your coal yard is out here. Your crushers crush the material, send it up to the plant. This plant has a scrubber located on the stacks. This is the limestone scrubber that I described. It's an entire, really, another chemical plant on the back end. After the coal is burnt and the process takes place, before the material or as the material is going up the stack, it goes through a scrubbing system where limestone removes the sulfur before it goes up the stack. So over in this area, there's a separate limestone processing area where the limestone is processed, put in these bins, and then used to scrub the emissions from the stack. This chart depicts the relative dependency of various countries on coal as their energy source. You can see they range from Botswana and Mongolia, where nearly 100% of their generation relies on coal, down to the United States, where we're using about 40 to 45%, Europe using somewhat less, and France and Canada have just about eliminated most of their coal-fired generation. Again, this chart is kind of gives you an overview of, as the developing country, as the country becomes more developed technology and standard of living, the percentage of reliability on coal decreases, where the countries that are still in the very early stages of economic development rely very heavily on coal. Some of the equipment, the TerraSource equipment used in coal-fired power plants, include the granulators, the gunlock roll crushers, frozen coal crackers, posimetric feeders and Jeffrey Rader vibrating feeders, compactors, and flex tooth crushers. Here's an overview. We see granulators on the top left. We see roll crushers, posimetric feeders. Posimetric feeders are used in a power plant both to feed the crushers. Well, actually, the vibrating feeders and the posimetric feeders can be used to either feed the crushers in the power plant or actually to feed the pulverizers. In the case of the posimetric feeder, we have many, many posimetric feeders feeding pulverizers. See here on the top left, our frozen coal cracker. See a Jeffrey flex tooth crusher on the right, and a compactor down the bottom here. Compactor is a very popular machine used to feed fluid bed, to prepare the feeds for fluid bed boilers for many reasons. It's an open bottom crusher. It's able to do its sizing strictly in impact. So this is a crusher that's used on very sticky materials. Materials like waste coals, petroleum coke, materials that would plug up a machine with cages or doing an internal sizing relying on passing through screens. This machine is able to handle stickier materials, which are very popular as fuels for fluid bed boilers. One other technology that's becoming more and more popular because it's a very clean technology is coal gasification. An integrated gasification combined cycle technology. With coal gasification, the coal is converted to a gas, and the gas is then fired in a combustion turbine, which is connected to a generator to produce electricity. The exhaust heat from this process can be sent to another generator, a heat recovery steam generator, that drives a steam turbine. So you actually get greater efficiencies than you would with a general pulverized coal plant, where you're only using the heat from the coal one time. Here's a depiction of a coal gasification process. The syngas, synthetic gas that's formed from the coal, is cleaned prior to combustion, and the impurities like sulfur are recovered as separate byproducts. The gasification results in lower emissions of sulfur dioxide, mercury, and particulates. The only downside of this technology is it's limited in how large a plant can be built right now, and it's still relatively expensive compared to pulverized coal plants or fluidized bed boiler plants. So the scope of and size of these power plants is smaller, but is increasing each year. The last subject that we want to touch on today is coal used in steel production. Steel is an alloy of iron and carbon, and the source of carbon in the steelmaking process is coking coal. Coking coal is converted to coke by driving off the impurities in a coke oven, leaving almost pure carbon behind. This pure carbon coke is then fed to a blast furnace with the iron ore and flux materials such as limestone, for example. The coal must be properly sized prior to charging in the coke oven, and that's where the TSG equipment comes into play. Equipment that's used in the production of steel include our reversible coal pactors and our gunlock cage pactors. These two pieces of equipment have been the choice of preparation of coal in steel mills for many years. The choice of whether to use the coal pactor or the cage mill really depends on the amount of crushing that might be needed to feed the coal to the coke oven, installation restrictions, where sometimes the cage pactor may fit in better to a given situation, and the amount of uncrushables or unwanted material that may be included with the coal feed. Generally, coke ovens require coal to be in the range of 85% passing minus of 1/8 of an inch, with a minimum of minus very fine material in the area of 100 mesh. So we're trying to attain a certain top size, but at the same time minimize the generation of extreme fines. Both the coal pactor and the cage mill are capable of producing the required top size without generating excessive material prior to charging the material to the ovens. Sometimes the coke plant will add material to the coal before it's charged to the ovens, materials such as sludges that they can get rid of by burning them in the coke oven along with the coal. And this can at times make the coal wet and sticky as before it gets processed in our crushers. And these two crushers are open bottom machines, again, crush strictly in impact and can handle the sticky materials before they go to the coke ovens. That concludes our presentation today, but I'd be happy to entertain any questions that you have, and my email address is shown here. Thanks a lot for your attention, and we'll talk to you soon.